Hi everyone. Today we are going to discuss the heat transfer through concentric sphere, or it is also called as thermal conductivity of the given insulating powder. So this is the complete setup of the heat transfer through the concentric sphere. So in this we have a sphere. This is a copper sphere which is having inner and outer spheres. So inner sphere is having a 100 diameter and the outside sphere is having 200 diameter. So between these two spheres we have some powder. So that powder is nothing but the asbestos powder. So this is packed in between the two cylinders. So now for this powder we are going to find out the thermal conductivity. Now if you go to the inside, the inside sphere is having 4 thermocouples T1, T2, T3, T4, and the outside sphere is having the other 4 thermocouples T5, T6, T7 and T8. Now here is the thermostat. So if you vary this thermostat, you can see here the voltage is being varied. So you have to arrange the voltage around 110 volts. So this is the voltage what we are adjusted here, and here this is the ammeter reading. You can see the digital ammeter reading. So if you adjust the voltage, automatically the ammeter reading is being changed. Like this, it is being varied. So now we are adjusting about 110 voltages. Now these are the thermocouple readings, temperature readings. So total we have 8 thermocouples which are located inside the concentric sphere. Now this concentric sphere is being surrounded with a glass chamber. Okay, so this is the concept of some conduction principle. So generally what happens in heat transfer, the higher temperature body will transfer the heat from higher to lower temperature. Now once you start the experiment, you have to adjust the voltage to 110, and now we have arranged the thermocouples inside the sphere. So this gives the first temperature reading T1. Now if you rotate the next temperature T2, you can see the variation in the temperature. This is the thermocouple second reading T3, next T4, T5, T6, T7 and T8. So all the 8 readings you have to take from this temperature knob. Those are the thermocouple readings. Now what you have to do, again go back to the first temperature. See, once you start giving the voltage to the sphere, slowly it starts being heated. So what you have to do, you have to wait until the steady state temperature is being reached. So what you have to do, you have to wait for 5 minutes, again take the readings from T1 to T8. Now check the readings before and after if there is any variation. So at least you have to take a variation of approximately 1 to 2 degrees centigrade. That's it. If it is ranging more than 2 degrees centigrade, again you have to wait for 5 minutes. Again you have to take other readings from T1 to T8 until the steady state temperature reaches to the sphere. You have to take all the readings. Now taking all the readings, so what you have to do, you have to take the average of the inner sphere, that is average of 4 thermocouple readings T1, T2, T3, T4, and again the average of outside sphere thermocouple readings T5, T6, T7, T8. Now you take the difference between the inner and outer sphere temperatures, that is delta T. Okay, after taking that delta T value, now you take that delta T and you substitute the value of delta T in the thermal conductivity formula in order to find out the thermal conductivity of the given powder. So in this we have asbestos powder. We can vary the powder. Different powders can be changed. For this example, we have taken the asbestos powder. So for this asbestos powder, we are finding the thermal conductivity. So this is the process of finding the thermal conductivity of the given powder, and this is also called as heat transfer through the concentric sphere apparatus. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.